Next we are going to see pole and polar. Consider the general equation of the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. That is equation number 1. Let p x1 y1 be any point inside, on or outside the circle. So any point which is lying inside, on, right, or outside the circle. You choose one point like that, right? So we are choosing a point p x1 y1 outside the circle except the center of the circle. So the point should be other than the center of the circle, right? Draw a chord AB through the point p x1 y1. So we are going to draw a line which cut the circle at 2 points. So we will have a chord which intersects the circle at A and B, right? Draw the tangent at A and B. So now we are going to draw a tangent, right, at A, at B. Let the point of intersection of this tangent be C, right? The locus of the point C is called the polar of p x1 y1 with respect to the circle 1. So the point of intersection of the two tangents, right, is C. The locus of that point of intersection is called polar of p x1 y1 with respect to the circle 1, right? So that is the moment of that point, right? If you are changing the tangent directions, right, so you can draw AB, from AB two tangents, right, their point of intersection is C. If you are changing the direction of the tangents, then you will get a path like that which is mentioned in the dotted line. That is the polar of C, sorry, polar of P, that is the path of C, right? And the point p x1 y1 is called pole. So the point p x1 y1 which is called pole, right? If you draw another chord DE through the point p x1 y1, right, so which intersect the circle at D and E, and draw tangents as D and E, right? So let the point of direction of these tangent be F. Then FC is the polar of P with respect to the circle, right? And the point P x1 y1 is the pole. See, if you are you can draw from a point, any point outside, on or inside, you can draw so many that is chords to the circle. So it cuts the circle at 2 points, right? So from those 2 points you can draw 2 tangents. The point of intersection of that tangent, right, the locus of the point of intersection of those tangent is called the polar of that particular point p x1 y1, and P is called, that point is called pole, right? Result, the equation of the polar of p x1 y1 with respect to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 is xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. Given circle is general form of the circle, that is equation number 1. So taking any point p x1 y1, draw a chord AB through the point p x1 y1. So it cuts the circle at A and B, right? Draw the tangents at A and B. So it intersects at C x2 y2, right? We know that the equation of the chord of contact AB at C x2 y2 with respect to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 using the formula, right, chord of contact formula, right? X x2 plus y y2 plus g into x plus x2 plus f into y plus y2 plus c equal to 0. That is equation number 2. Since p x1 y1 lies on AB, right? Clearly the point P is on AB, that line, right? But AB equation is represented by the equation 2. Therefore p x1 y1 satisfy equation 2, right? So put x is equal to x1 and y is equal to y1 in 2. So you will get x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c equal to 0. That is the equation number 3. 3 implies the point C x2 y2 satisfy. So you are taking the reverse idea, right? So this point x2 y2 satisfy the equation x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. So put x instead of x you put x2 and instead of y you put y2. So you will get equation 3. So x2 y2 satisfy this equation, right? So the locus of the point t x2 y2 is x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c, right? Therefore the equation of the polar is x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. Note, if the point p x1 y1 is an exterior point to the given circle, then the chord of contact p x1 y1 is the polar of p with respect to 1, right? So if it is outside the circle, then chord of contact is the polar, right? Suppose the point lies on the circle, then the p x1 y1 is on a circle, then polar is coincide with the tangent at p. So if it is on the circle, then the polar is nothing but tangent at p, right? So p x1 y1, then this is tangent at p, right? If the point p x1 y1 lies inside the circle, interior point, then the polar p x1 y1 does not intersect the circle. So suppose if it is inside, so you can draw another chord. So draw the tangents. So right, so first chord AB, through P we are drawing chord AB, and then you are drawing the chord CD, right? You can draw so many chords, right, through P. Then you draw the tangents at A, at B intersect at one point, and at C, at D intersect at one point. So that is 2 brown line, 2 green lines, right? The point of intersection. So the point of intersection is the locus of the polar, right? So that is the one. So this is called polar, right? If C minus G minus F is the center of the circle 1, then the slope of the line joining C minus G minus F and P x1 y1 is, we know, 2-point formula of slope, y1 plus F x1 plus G, y2 minus y1 by x2 minus x1, right? Slope of the polar is, so this is, so polar is perpendicular to that line, right? Line joining the point C and P. So it will be minus x1, that is reciprocal of that slope, x1 plus G by y1 plus F, right? If M is the slope of one line, then its perpendicular line slope is minus 1 by M, right? Reciprocal with, you have to add negative sign, right? So polar is perpendicular to the line CP. The equation of the polar p x1 y1 with respect to the circle x square plus y square equal to r square is x1 plus y1 minus r square equal to 0. Thanks.